In the name of God. Hello, dear students. My name is Masood. I'm a physics teacher. We are here in Fairhaw's website to explain physics curriculum, grade 11. In previous lessons, we talked about the motion with constant acceleration. We proved, till now, we proved three rules from the four rules that are mentioned in our textbook regarding the uniform motion. Regarding the motion with uniform acceleration, uh, actually, right now we are going to, let's say, solve uh, problems within this practice 1D, page 19. Let me read the question number one. A car with an initial speed of its initial speed of, this speed is repeated twice actually. This one is additional. A car with an initial speed of this number, 23.7 kilometers per hour. So initial speed is given, VI is known. Accelerates at a uniform rate of 0.92 meters per second squared. This is acceleration for 3.6 seconds. And this number is delta t time interval. Find the final speed. So we look for final velocity. Find the speed, find the final speed, and displacement. Displacement is unknown as well of, of the of the car during this time. Right. So what are the information within the question? Are informations are unified or not? Let's take a look at the summary of the information within the question that I gathered it in a table. Initial velocity is this number, 23.7 kilometers per hour. Delta t is given in second. That's why we have to convert the kilometers per hour into the meter per second, because let's say, for example, 3.6 second. This is 3.6 second. 3.6, not 6.5. 3.6, because converting 3.6 seconds to the hour uh, takes a, actually it's not very common. It's not nice to convert only 3.6 seconds to hour. The result is gonna be in the, let's say, some decimal points, and it's not nice in our calculation. So the best way uh, is to convert the kilometers per hour into the meter per second. And we have acceleration as well. I didn't mention it here. We have to mention it here. Acceleration is equal to 0.92 meter per second squared. Maybe I didn't mention it because we don't need it. Yeah, we need it here, but I forgot maybe to mention this acceleration here. Right. The first step, V final, we look for V final because it says find the final velocity, this first one, and displacement, delta x. Right now, we are going to find the final velocity by means of this equation. Final velocity is equal to initial velocity plus a delta t. V final is equal to 6.6. Maybe you see, teacher, where does this number come from? It comes from the conversion of 23.7 kilometers per hour to meter per second. And what's the conversion factor? Go over it. Conversion factor for kilometers per hour to meter per second is 5/18. That's why 23.7 multiplied by 5, the result divided by 18, and the answer will be approximately 6.6 meter per second. That's why initial velocity uh, is equal to 6.6 plus acceleration 0.92. I mentioned it here. We had it within the question. Delta t 3.6 3.6 seconds, right? This value, and 6.6 remains as it is. Multiply these numbers to get 3.3 and add them up together, and the answer is almost equal to 9.9 meter per second. This is the first step. So we could find the final velocity by means of this step. Right now we are going to move to another step to find the displacement by means of this information. Right. Delta x is equal to vi delta t, initial velocity times delta t plus 1/2 a delta t squared. Right. Delta x is equal vi initial velocity. We've already converted it to meter per second, which is equal to 6.6. Delta t 3.6 plus 1/2 acceleration 0.92. Delta t 3.6 squared. Multiply these numbers together to find this value. Squared, I want you to square 3.6, means 3.6 times itself. After that, you have to times it actually by 0.92, and the result, you have to divide it by 2 to get 5.96. I want you to add these numbers up together to find the last answer, which is equal to 29.7 meters. This is delta x, right? So this is the first question. I solved it for you. Let's move on to another question, which is question number 2, regarding the laws of motion with constant acceleration. And we have, I told you, we have 4 rules in our textbook, maybe in other source. Whenever you search for other sources, uh, maybe you find more than 4 rules. But here we obey the textbook, right? Let me read the question number 2. An automobile with an initial speed of 4.3 meter per second. So this is the initial, right? The initial accelerates uniformly, means it speeds up at the rate of 3 meter per second squared. It's approximately identical to the previous question, if you remember. So this is acceleration, just the numbers are changed, right? The form of the question is approximately the same. Find the final speed. We see final speed means we look for VF, and we had this unknown in the previous question. And displacement, we had delta x as well in the question, in the previous question. After 5 seconds, only the numbers are changed, but the actual form of the question uh, are exactly copy paste to each other. But here we have one more difference between these questions. Here units are unified. We don't need conversion here, so it's a little bit easier than the previous question. Right. Initial velocity 15 meter per second. It's not 15, actually it's 4.3 meter per second. 4.3. Final velocity, we look for final velocity. So this table is not, the information within this table is not very accurate. Delta t is 5 seconds, and we look for 2 things, delta x and v final. Firstly, I want you to find the v final. V final is equal to v initial plus a delta t. This is the first step. V final is equal to v initial 4.3 plus acceleration 3 times time interval, which is equal to 5. 3 times 5 becomes 15. Bring it down, and bring down the 4.3. Add them up together to get the last result, which is equal to 19.3 meter per second. Let's move on to another step for finding the displacement of the automobile. delta x equal to 1 half vi plus vf within the bracket multiplies by delta t. Delta x equal to 1 half initial velocity 4.3, final velocity 19.3. We've already found it in this step. 19.3 times 5. Delta x is equal to 1 half. I want you to add these numbers up together within the bracket, multiplied by 5, and the result divided by 2. That's why the answer is 118 divided by 2 will be 59 meters. Maybe there are more options for finding the delta x. You can use other rule like this rule. Delta x is equal to v initial delta t plus 1 half a delta t squared, right? You can use this rule as well because initial velocity is given, time interval is known, acceleration is given, and you are free. I told you last lecture, you are free to use any rule. It's optional. And thank you very much for watching this video, and bye bye.